Hi guys, how you doing? I just figure I've been missing your lovely faces, and so maybe you've been missing my lovely face too. No, I'm not gonna do this the whole time.
Okay, so anyway, I thought I'd try something a little bit different today. I'm kind of regretting it right now. This is about my fourth or fifth time through the video, and things just aren't working out the way that I was hoping. So hopefully you actually see this video. If so, know that I apologize. It's a little bit late, but I am just trying to get things to work out in a way that hopefully will be a little bit more helpful for you as we work through. Okay. So we're looking at cubics today, cubic functions. You can see I've already written one down here on the right-hand side. And so this is the one we'll work with. We're going to go through two in this video. Right now we're just working on graphing cubics, okay? Now this is going to be very similar to a lot of the stuff you've already done, okay? You've already done some stuff with graphing. You've done linears, you've done quadratics, okay? Recognize that your linear graphs, right, it was just a straight line, no bends, no curves, no changes, anything like that. So that was pretty straightforward and pretty simple. Then we moved on to quadratic graphs, which had one single bend. Either it was going up and then started going down, or it was the opposite way. It was going down and then started going up, right? And so you had one bend there where it changed direction. It had one type of change. Okay, so cubics are going to be very, very similar. I think you've done these in Algebra 2. This is mostly just kind of review, but I do want to talk about a couple of things that will be expected of you. So you should have, you know, something, this has two changes, right? So it was going up and then started changing, so it was flattening out or going down, and then it starts going up again. Those are two different bends, two different changes. You can have something doing the opposite as well. Okay, sometimes you have a minimum and a maximum, a local or what's the other word? A local or a I don't remember the other word right now. I said it about 10 times in the other video that I've given up on. But yeah, it's a local, a relative minimum or maximum there. Okay, sometimes there are no relative minimums and maximums. In this case, there might not be. Sometimes your cubic even looks something like this, where there's definitely not two minimums and maximums, but you still do have the two bends. One bend where it was going up, starting to go down a little bit, and then it goes to where it starts going back up again, right? That's two different bends. You should see those two different bends every single time you do a cubic function like this, all right? Now, HLs, of course, you guys are going to get to do some other fun, interesting things with this, but for the most part, SLs, we're focusing on getting the graphs and being able to do interpretations and things like that. Exactly what you've done with your linears and quadratics, which is why we're not going to take too much time to go through this, but we are going to try it and see where we can get, all right? So I'm going to go ahead. What I would like for you to do, if you need to, pause the video. We're going to do some stuff with the calculator today. Unfortunately, I don't have my Inspire with me. I wasn't planning on bringing it with me, and it's in China right now, and I can't get back to it. I'm sorry. So you will need to use your Inspire. If you don't have your Inspire, do it on Desmos or something online, but make sure that you do get some practice doing it on a calculator, because some of the functions and other things that are on there will be necessary. You need to be comfortable with those, okay? I'll try to mention as many of them as I can, but for the most part, if you're not sure how to do it, just look it up on YouTube. There's lots of videos on YouTube about how to use the TI Inspire and look up a specific function, all right? Or how to find an x-intercept or whatever else, but I'll try to mention most of those as we go. All right, so here we go. We're going into the meat of the first part of this lesson now, which is just graphing the quadratics. All right, so if you haven't done it yet, please put in x. Man, if you can, please put in x minus 2 to the third power and graph it. I would like for you to start in the standard window. So if you can go into the menu and go to the window and just go to window standard. That should take you to the normal. It'll go 10 in the x direction, 10 in the y direction. It'll go positive and negative, right? Now, if you do that, what should happen is you should get a graph that looks like, I'll put it up right here. Here we go. Sorry, I know this is a little bit annoying, but if I pause the video, I notice I lose the video. Yeah, I learned that after 3 or 4 times. Okay, so your graph should look something like that if you're in the standard view. Okay, now you'll see that as we talked about before, we can see the two bends, right? It's going up and starting to bend downwards a little bit. It doesn't ever start going downwards. It's just bending in that direction, but then it bends back up again. So we can see both the bends. So we're good with what we can see here as far as the cubic is concerned. Okay, now remember when we're sketching, there's some important things we should always include. We should always include the x-intercept, which we can see right here is 2, 0. Okay, we should always include the y-intercept, which is right here, which is 0, -8, right? You may be able to read that off your graph. If not, then remember the ways that we found x-intercepts and y-intercepts before. You can always get the x-intercept by using the zeros function, right? That is inside of your menu, Analyze Graph. And if you go there, then there's an option for zeros, and you just choose a value before that 0, you choose a value after that 0, and it will give you the 0. Okay. Remember, for the y value, what you can do is you can do the menu Analyze Graph value, and for value you can type in any x value, and remember, to get a y-intercept, all you have to do is put in a x value of 0. So you just type in 0 and push enter, and it should give you the y-intercept as 0, whatever the y-intercept is. Okay. Now in this situation, we don't have relative maximums and minimums, which normally we would do for a quadratic or cubic or anything other than that. This situation, there really aren't. We have a situation that looks a lot like this one right here, where it starts curving, but it doesn't ever really start going down again. So we don't have any relative or local maximums or minimums. So in this case, it would be a good idea just to pick off a couple more points, just so that we can have a nice smooth curve. Lots of ways to do that. You can go into your Analyze Graph and do Trace. And if you do Trace, you can just move along the graph, and it'll give you a couple more points there, just so you can make sure that it's nice and clean. Or you can go into Table, and there's a button for Table. And if you go to the table, it actually gives you a whole table. Gives you a whole table of values that you can use, right? So you can put in, you can just follow the table, and you can scroll up and down. You can look at whatever values you want there, and you can get a couple more points that'll fit on your graph, so you can make it nice and smooth. All right, so that's graphing. So that's actually the first little bit here. That's the first thing I wanted to show you. What I do want to do, though, is I want to show you one that's a little bit more complex situation. And so I'm going to go ahead and take off what we have here. I'm not going to put on a new graph yet, because we'll get there in a second. But I'm going to put up our new equation right here. And so our new equation right here. Ooh, there we go. Put it right there. So f of x, or y, equals x cubed minus 7x squared plus 4x minus 12. Go ahead and put that into your calculator. Okay. Now, if your calculator is still in that standard window, then your graph should end up looking something like this. Whoop. Man, that's snazzy. I did learn a thing or two, even if it took me a while. So this is what your graph should look like right now. Now, this is not what our cubic should look like, right? We can't see the two bends there, okay? Now, if you look really closely, you can see the graph that it's kind of coming down, and then it starts bending a little bit over to the left. Now, what this makes, noticing details like that is going to help you in the long run. Because what it looks like to me is that I have a graph, and I'm going to draw it right here in the middle, is that it looks like it's coming down, and it's starting to curve a little bit like that. Okay, so my guess is that it's either going to curve down from that point, or it's going to give me the little two bends that I'll be able to see clearly. Whichever one it is not important right now. We'll see it in just a second. But what it does mean is that I'm only seeing the top of the graph right now. I need to see more down here below. So what you're going to do is you're going to go into your window, right? Go into the window settings. This time go into the place where you can actually change the x and y values. Leave the x values. I think -10 to 10 is probably enough right now. If it's not, we'll change it later, but we definitely need to see further down below. So change that minimum y value so that it's -20, -30, -40. Play around with it a little bit, all right? So I want you to look at that and give it a try and see if you can figure out exactly what you need to change it to, and hopefully you'll end up with something looking like this. Lovely. I'm getting better. I really am. All right, so there, that's what your graph should look like. Play around with that window. If you can't figure it out on your own, then look at mine, right? I've got my minimum y is -50, and I've got my maximum y is 10, and then my x's go from -10 to 10. And I can clearly see the two curves here, right? The two bends. I need to make sure on a cubic I can always see those two bends, all right? Now, just like in the other one, we're going to find x-intercepts, we're going to find y-intercepts, we're going to do all those other things. All right, so x-intercept, again, using the zeros function, you should be able to get that. Your x-intercept should be about 6.67 comma 0. All right, now if you need to, pause the video, okay? Don't just sit here and stare at me and go. Pause the video, try to find these points on your own, and then when I talk through it, just double check that you got what I got. All right, so go ahead, do that. I'm going to go ahead and finish up what I was doing. So I got my y-intercept here using the value function. And so the y-intercept is 0 comma negative 12. That's a negative right there. Okay, now I need my relative minimum and relative maximum. The minimum is going to be 4.36 comma negative 44.7. Make sure when you do your minimum that you only include this area right here. If you go all the way over here, then it's going to give you a different minimum. Right? It's going to say, well, your real minimum is down here. We don't want that. We want the relative minimum, the minimum of this section right here. So that should give you the 4.36 negative 44.7. You also need the maximum right there, and that maximum is going to be 0.306 comma negative 11.4. All right? So that gives you all the points that you need. With that, you should be able to then transfer that over to your paper, mark each of these points, label each one. It doesn't have to be perfect, but you do need to have all 5 of these, 4, I can count, I promise. All 4 of those points, the two intercepts, the x-intercept, the y-intercept, the maximum, the minimum, and then from there you should be able to make a nice smooth little curve, okay? Pay attention to some other details. This down here doesn't go all the way out to -5, right? It's somewhere close to -2 at this point, so make sure that as you're graphing it that it's close to that, okay? Otherwise, you should be able to make a pretty nice sketch, and that's all we're doing in this first video. Go ahead and practice a couple of those, and then you can go on the next video and we'll see how it goes. All right? Thanks, guys.